Every 100 minutes, another football field of Louisiana disappears into the Gulf of Mexico. The reason is not just the storms. The reason is the levees. The mechanism has a name: sediment starvation. It is what happens when a river that spent 7,000 years building a coastline is no longer allowed to flood, when the system designed to protect that coastline cuts off the only process that sustained it. The levees are working, the floodgates are holding, the pumps are running, and the coast is still going, not because the system failed, because it succeeded. If this kind of analysis is what you look for on YouTube, subscribing to Earth and Empire takes 1 second. There is more of this. Look at a satellite map of coastal Louisiana. What you see does not look like erosion. It looks like dissolution. The marshland is not receding at the edges. It is breaking apart from within. Open water channels spread through it. Small islands shrink. Bays appear where solid ground used to be. Since the 1930s, Louisiana has lost approximately 2,000 square miles of coastal land. That is a loss roughly the size of Delaware. Gone, not flooded, not submerged. Gone, compacted, drowned, and consumed by the Gulf. The rate of loss has slowed in recent decades, partly because of restoration work, but the trajectory has not reversed. The math has not changed. Before we can understand why, we need to understand what the Mississippi Delta actually is. Not a place, a process. The Delta did not form because Louisiana happened to sit at the mouth of a large river. It formed because that river repeatedly flooded over thousands of years, and every time it flooded, it laid down sediment. Fine silt and clay eroded from across the continental interior. Material from the Rockies, particles from the Appalachians, all of it moved south by current. Then it spread across the flat coastal plain when the river overflowed its banks. A thin layer each year, enough to build, enough to stay even with sinking organic soils, enough to hold land at the surface of the water. That process, flood, deposit, build, created the Louisiana coast over roughly 7,000 years. And it required every year that the river be allowed to flood. In April 1927, the Mississippi River flooded 27,000 square miles across 7 states. More than 500 people died. Hundreds of thousands were displaced. The political response became one of the largest engineering commitments in American history. Congress passed the Flood Control Act of 1928. The Army Corps of Engineers was tasked with controlling the Mississippi, completely, permanently, at scale. What followed was extraordinary: levees, floodwalls, concrete revetment, control structures, thousands of miles of engineered flood defense built over the following decades. It worked. Major flooding of the lower Mississippi Valley became rare. Cities were secured. Farmland was protected. The engineering was celebrated rightly as one of the great achievements of the American century. But something did not make it onto the balance sheet. When the Army Corps locked the river into its channel, it did something 1928 could not fully measure. It turned off the Delta's engine. Before the levees, the Mississippi spread sediment across the coastal plain every spring. The river did not stay in one place. It wandered, it flooded, it built. After the levees, the river ran between walls. Its sediment could no longer escape the channel. It traveled south in a confined, fast-moving current. It reached the mouth of the river. Then it crossed the edge of the continental shelf. Not onto the Delta, into the Gulf, into the dark. The Delta, deprived of annual replenishment, began doing what organic coastal soils do when they are not fed. They compact, they oxidize, they decompose, they sink. The technical term is subsidence. The land surface drops, not because it is being washed away from above, because it is collapsing from underneath, unsupported and unreplaced. In parts of coastal Louisiana, the ground is sinking at rates measured in fractions of inches to more than an inch per year. As it sinks, the Gulf moves in, not dramatically, not in one catastrophic surge, quietly, permanently. The levees did not fail. They worked exactly as designed. That is what makes this a trap, not a mistake. The levees didn't save the delta from the river. They saved New Orleans from the river and spent the delta in exchange. Everything else, the hurricanes, the storm surges, the flooding, is downstream of this. Literally. When the coastal marsh buffer shrinks, storms reach the levees with less resistance. When the land sinks, the geography that once absorbed surge energy disappears. The storms are not getting deadlier in isolation. They are getting deadlier because the terrain they cross has been compromised by the system meant to stop them. Now consider what sits on top of this disappearing coast. Louisiana is not only a state with scenic bayous, it is one of the most important energy corridors in the United States. The state holds about 1/6 of the nation's crude oil refining capacity. It hosts major LNG export terminals on the Gulf Coast. Its pipelines, ports, refineries, and terminals connect Gulf energy to national and global markets. And New Orleans sits near the center of this system, not on solid ground. Much of New Orleans sits close to, at, or below sea level. Some parts are several meters below it. The city exists because an enormous drainage system keeps water moving out. Pumps run through storms, routine rainfall, and ordinary days. Without them, large sections of the city would flood quickly. The pumps depend on the levees. The levees depend on land around them for storm buffer and structural support. The land is shrinking. This is the double bind. The levees cannot simply be removed. Take them down, and the flooding is immediate, catastrophic, and irreversible. New Orleans floods. The refinery corridor is exposed. Pipeline networks are threatened. The agricultural export system is disrupted. But the levees cannot be kept without continuing to starve the delta. Keep them, and the coast keeps shrinking. The storm buffer keeps thinning. The pressure on the levees keeps increasing. The catastrophe the levees were built to prevent keeps moving closer. There is no lever that resolves both sides at once. There is only a choice between immediate disaster and deferred disaster. This is what structural dependency looks like, not a failure of planning, a physical lock-in, a system so successful at its primary function that dismantling it is impossible and maintaining it is unsustainable. Louisiana is not a singular case. Every major river delta on Earth, once fully controlled, begins to face the same arithmetic. The Nile Delta is shrinking. The Yangtze Delta faces the same pressure. The Colorado Delta is essentially gone. The mechanisms differ by river, but the rule is the same. Deltas are not features of the land. They are processes. They exist only as long as rivers deliver sediment and floods. Control the river completely, and you stop the process. Stop the process, and the land it built begins returning to the sea. What America constructed in 1928 was not simply a flood control system. It was a commitment to a certain relationship with a natural process. Total, engineered, permanent, and that relationship carries a geological price. The price is not paid at the moment of commitment. It is paid on Earth's timeline, slowly, then suddenly. There are serious efforts underway to address this. Louisiana has a coastal master plan measured in tens of billions of dollars. Sediment diversions, river reconnection projects, and marsh restoration programs are trying to reintroduce land-building processes. These efforts are real. They matter. In some places, they work at the margin. But rebuilding 2,000 square miles of lost delta is not a small repair. And keeping pace with ongoing subsidence makes the target move while the work is underway. You can extend the timeline. You cannot reverse the physics. If this video changed how you see the Gulf Coast, or how you think about engineering and its geological depths, Earth and Empire covers nothing else. Subscribing keeps that work going. We call it a coastal crisis. We frame it as a climate problem. We describe it as Louisiana's problem. The mechanism at its center is not any of those things. It is the story of what happens when you tell a river it cannot flood. It will obey. It will obey for a generation. It will obey for a century. And the whole time it is obeying, the land that took 7,000 years to build will be quietly returning to the sea. The levees are working, the pumps are running, the floodgates are holding, and the coast is still going. Not because the system failed, because it succeeded. And success at this scale carries a geological debt. The Earth did not need to overwhelm Louisiana. It only needed to wait.